Good afternoon, ladies and gents. So today, if you were absent, you guys missed these little bit of notes that we talked about with our SI units. And so the first thing we did was talk about Friday and Tuesday, where we did our walk around activity going through measuring volume, measuring mass, measuring length. So there were some units that we wanted you guys to use and some units that we made sure that you were not using. So remember, I know we are in the U.S., and in the U.S. we use miles, we use inches, we use feet. Right now, though, you are in a scientific class, you are in a scientific community, so you will be using that metric system. So with our metric system, some of the units that we used, G stands for grams, which that describes an object's mass. L stands for liters, which describes an object's volume. M stands for meters, which is a measurement of length or distance. Okay. On Friday and Tuesday, some of the equipment that you used to measure that mass, volume, and length was a meter stick for length. You used a scale or a balance for your volume, and then scale or balance for your mass, and then volume was your graduated cylinders. Okay. So those were just some of the things that we had placed around the room, and you were reading them, getting different graduated cylinders, different measurements, and then that kind of factored into which one was more accurate and which one was more precise. So when we look at precision versus accuracy, we had 3 balances, and I took that eraser and I put it on those 3 different balances. The first one read 8 grams, the second read 8.1, and the third one read 30.01. So as I look, the first scale only went to the whole value, the singles place, right? The second scale went to the tenths place, and the third scale went to the hundredths place. So as you went from scale 1 to scale 3, they became more precise. But if you notice, that third one threw you for a loop. There was a really precise answer, but it wasn't necessarily accurate. So if I'm comparing my 2 ones that I highlighted in orange here, 8 versus 8.1, 8.1 is more precise and it's more accurate. So think of precision as how specific are you being. So for example, I can say you guys are in your teens, but I may not know that you are 14 years, 10 days, and 20 hours old. Okay, so that's more precise, but might not actually be more accurate. So you got to be careful. So precision, how specific you are, how many places past the decimal you are including, whereas accuracy is just how close you are to the true value. All right, taking a look over here for our last question that asks about volume. If I'm looking at this, I see this meniscus, and this is what I read in order to get my volume. So I'm looking there. And I would say I am definitely certain that it's 21 and not 22. But I don't know if that's 21.2 or 21.3 or 21.4. And that's because there's no extra little tick marks there. The more tick marks you have, the more certain you can be with your answer, and the more precise. So as I look at that value, it might be 21.2, it might be 21.3, I don't know, right? So this is my estimated digit. So I do have my level of certainty, so I'm certain it's 21, and then I only estimate 1 digit past that. So if, for example, on this one, say we didn't have any tick marks. Okay, so say there's no tick marks there. And instead, this is all that you get. Would you know that that's 21.2? No, right? You're definitely certain it's more than 20, but less than 25, right? So we would definitely be certain of the 20, but if it's 21 or 22, I don't know, right? So I'm certain of the first 2, and then the last digit is the one that I would estimate. So depending upon what measuring device you use, you can be more or less precise based upon your degree of certainty. So when you were measuring with that meter stick on Friday, the one side just said 1 meter. And you're like, here's my finger. I don't know, like maybe it's 0.1. I couldn't tell because there was no extra tick marks on there. So that makes it a little bit more challenging. All right, so last week's activity kind of led us into this week as we keep working through those SI units and taking a look at some of those conversions. So for today, we're going to start introducing the staircase method, which hopefully you guys remember a little bit, okay? There are some conversions that you already know. You might not know that there's 100 centimeters in a meter, but you could tell me there's 100 years in a century, or a decade has 10 years. So those are prefixes, and those prefixes are all based upon a power of 10. So if you ever wondered why the metric system is so awesome, is because it uses the same base, but just increases its measurements based upon the prefix by a power of 10. So 10 to the 1, 10 to the 2, 10 to the 3rd, 10 to the 4th, 5th, 6th, etc. So as you go up from meters to kilometers, a kilometer is a bigger distance. You can go even higher and go mega or giga, or you can go the opposite way and go smaller all the way down, centi, milli, micro, and nano. Okay. So those increments of 10, you guys have seen this hopefully at some point in time. But let's say that I start with 1 meter. You guys know now that there's 100 centimeters in 1 meter. But how can I use this staircase in order to figure that out? Well, as I go to the right, or I go down my staircase, I'm going to multiply each step by 10. So 1 times 10 gives me 10 decimeters. Times that by 10 again, I get 100 centimeters. Multiply that by 10 again, I get 1,000 millimeters, which you guys know there's 1,000 little tiny tick marks on that meter stick. So one way that you can do this is just multiply each step as you go down by 10. If, though, you want, there's a faster way to do it, and that's by moving the decimal place. So there's a decimal right after that 1, and then to get to the next staircase, I'm going to move it 1 place, and now it's 10. Move it 1 more place, and it's now 100. Move another place, and it's now 1,000. And you notice that I fill in those blanks with a placeholder 0. Okay, so as you're going down the staircase, you're moving to the right and or multiply it by 10. Either or. Both ways work. Doesn't matter. If you're going up the staircase, though, let me clear this out. If you're going up the staircase, though, you are going to divide by 10 or move the decimal to the left. So if I start with 5,000 milliliters, that is 500 centimeters, or 50 decimeters, or 5 meters. Okay, so that time I did have to move my decimal to the left each time. And as I moved it to the left, it gave me a smaller number. Okay, so you can do it either way. It does not matter. Okay, whichever one you feel more comfortable with. So I do have a saying in order to keep track of all my prefixes, and that saying is King Henry died unexpectedly drinking chocolate milk. So kilo, hecto, deca, units for unexpectedly, meters, liters, grams, deci, centi, and milli. So let's give it a try. Let's see if we can do this. So I have 5 meters, and I would like to go to kilometers. All right, so if I want to go to kilometers, I'm going up to the left. So that means I need to move my decimal to the left or divide it by 10. So 5 divided by 10 gives me 0.5. 0.5 divided by 10 gives me 0.05. 0.05 divided by 10 gives me 0.005. So there would be my final answer, 0.005. Or move your decimal. There's my decimal. Move it 1 place. Move it 1 place. Fill in with a placeholder 0. Move it 1 place. There's your other placeholder 0. So you can do it that way as well. Or as you start getting good, you might notice, hey, I need to go up 1, 2, 3 staircases. So I'm going to move my decimal 3 places. 1, 2, 3. And then I fill in placeholder zeros. There is my 0.005 kilometers or kilometers. On this next one, if I start with 31 grams, or sorry, 31 milligrams, and I want to go to grams, I need to, again, go to the left. So I'm going to move the decimal to the left or divide it by 10. So 31 divided by 10, 3.1. 3.1 divided by 10, 0.31. 0.31 divided by 10, 0.031. Or just move your decimal. And your final answer, 0.031 grams. Okay, so you're just using a different prefix to describe the amount. It's not that you actually have less. So I'm going to do 1 U.S. customary just to be nice to help you guys put this in perspective. If I have 2 feet, I know 2 feet is 24 inches. So it's a different number, but the ending final unit is what's going to impact. It's the same measurement of length, but it's just expressed in 2 different ways. So same deal here, 31 milligrams versus 0.031 grams. It's still the same amount. It's just expressed with a different unit. If I'm going down the staircase here, 25 hectograms, and I'm trying to get to grams, I'm going to have to multiply it by 10 or move the decimal to the right because I'm coming to the right. So 25 times 10, 250. 250 times 10, 2,500. Boom. That's it. For the last one that we're going to try together, we're starting at 10 kilograms. We're trying to go to centigrams. Boom, boom. So I have to move it down 1, 2, 3, 4, 5 spaces. So I could just go 1, 2, 3, 4, 5. There's my 5 spaces, right? Or I could say, okay, take my 10. Here's my decimal point. Move it 5 spaces. 1, 2, 3, 4, 5. Fill in with zeros. And I get 1 million centigrams. So it's totally up to you. You can do it a variety of ways when converting between kilograms to centigrams or any of these metric prefixes. Okay? So for today, if you're at home, okay, for those in regular Science 9 or regular physical science, you guys are trying that Metric Mania. You're just doing the odds, not submitting it today. Okay? If you are in honors, you're going to do all of them and then submit it at 11:59, including the challenge problems. Okay? So regulars, odds today. Tomorrow we'll pick back up in class and we'll do evens tomorrow in class, and then we'll submit it tomorrow. Not tonight though. Okay? All right, have a great